Hi everyone. Today we are going to learn about different types of chains that we can generate using your Ollama and Langchain. Okay. So coming to that different chains, we have basically we have Langchain expression language. So Langchain expression language is actually responsible for us to use all the chains, different types of chains. We can utilize them with different available libraries from the Langchain Git profile and their available classes and their available methods. So with this, we'll be understanding how we can create a chain. So what is the purpose of using this chain? But also we will see with some hands-on. So this is actually if you have any two runnables. Runnable means if you have two executions which are to be done. So where we can make it happen in sequence or we can happen it using parallel or many other means. So what are all those means? We will see them in more detail. So all these runnables will be actually invoked by using your invoke method call. So this invoke method call is especially useful for us to actually understand how we can invoke each and every chain execution. Here chain means we know already what is a chain. It's a sequence. That means everything have a sequence. Next execution is dependent on the previous execution and so on. So basically a chain operation is a sequential chain operation. So to perform this chain operation, we have an operator called as pipe operator. It is just a straight line. It will be available beneath your backspace. And or else if you are not using that pipe operator, we can use even pipe method. So these are all the two things actually which will make us to understand how to create chains. Next, coming to different types of chains. We have five different types of chains. One is your sequential chain, next is parallel chain, next is router chain, next is chain runnables, and next is we can create custom chain. We'll more focus on all top first four chains because custom chain it depends on our requirement. If they are required, then we can use that. But anyhow, this custom chain will be coming in the top four chains even as well. Now we'll start understanding what is sequential chain. So when we want to use a sequential chain, for suppose if you want to have an output like this, like extracting keywords, you want to extract keywords from a given sentence. Generally, that will be done when a sentence was given to understand its language, to understand its meaning, and whenever this extraction of keywords will be generally we'll be using them in your day-to-day applications like your WhatsApp, and also when nowadays whenever we are drafting a mail, our mail engines like your Microsoft Mail Engine or our Google Mail Engine, they will also recommend the next upcoming word what we want to use as well. So these are actually real-time applications. For suppose if you want to develop our own application, this sequential chain can also be useful. And for suppose if you want to use such keywords, what keywords actually we can actually use them. Even though your model recommend one keyword, you will also think whether we can use that keyword or not. That's what we are doing in our WhatsApp. Even though the WhatsApp engine, WhatsApp Messenger, whatever it was suggesting for us to use, we will think twice or thrice whether we can use that word or not. So likewise, to generate it automatically, you should also understand whether it is a fact, that fact can be used for us for our application or not. And also, we'll also work on how to create a poem by understanding that fact table, fact even. We'll start programming how to start this sequential chain. So we'll be just creating a fresh file with the support of Jupyter Notebook. So as we have already practiced, we can use Langchain. So from we can use Langchain. So generally we are already using that Langchain Ollama. So from Langchain Ollama, so let's import your chat Ollama. Okay, so chart Ollama is responsible for us to integrate all our the model, whichever model we have in our local machine, that model we can use. And now we want to use from Langchain dot Langchain core. So from our Langchain core, let's use prompts, because all the prompts, whatever we want to generate, we want to use them. So from this prompt, let's import. So there are so many classes. We have seen the responsible classes like system message, prompt template, okay, and as well as human message prompt template, and as well as your chat prompt template. So these three are responsible. uh, we have used previously as well to understand what is system message, what is human message, and what is chat prompt template. And we know our base URL. So base URL is nothing but our local host. That local host can be identified like HTTP. So this is the base local host URL. You will get local host 11434 is the port number of the locally installed Ollama server. So this model name that should be already installed in our systems. So the model, whatever it was available in my local machine, is Llama 3.2 with 1 billion parameter model. Now let's create your LLM. That means whatever model that you want to use with the help of your chart Ollama. So in this chart Ollama, now I am going to give this base URL, which is equal to base URL, and also the model as model. So these are the two things that I am actually creating with your LLM. So if we just create this LLM, so it is going to give us an output, what is your model, what we are using in the base URL. Now let's create our system message prompt template with a variable called as system. So in this system, the system message prompt template, as we have already importing from your Langchain core prompts. So here we are using a template from a method called as from template. So from template, I am going to give a simple thing like you are. So we are going to give a prompt with a variable or like a placeholder called as which type of school teacher that you want to explain the things. Okay. And we are also asking, that means we are giving a prompt how to answer by the, so it's just a prompt we are providing it to our model. Which model? That is your Llama 3.2 1 billion parameter model. And also let's give a question. So for question, that means whatever we are trying to give, that is your human message prompt template. So for this also we should use your from template method. So in this from template, so let's give, tell me about the whatever topic that you want to give. So that variable that I am using, and how many points you are expecting and your points. So this is a system message and this is a question that I want to create. Now I will list them in your message list. These both system and your question. Next, let's create a template by calling your chat prompt template. So in this, we'll pass this system and question list of items. Next, let's update your question by invoking your template, because the template contains your messages. So for this, we are going to use invoke method. Okay. So whatever variables we have used, so we have used school. So for this school, I want to give, so school being it is a string type of variable. So school, so what is the value that you want? For suppose I want to give the value as primary. Okay. And similarly, we have used another variable called as topics. So in this topics as well, we want to give So let's the topic be solar system. Okay, and the other thing we have given is points. How many points of AI message that you are expecting? You are expecting your AI message to display. Okay, so those points, let it be 5. Okay, this is what the question that I want to invoke. Now let's ask to give a response. So we are creating a variable called as response where I will invoke my LLM. LLM. So we are passing this question because this question, now updated question value contains your placeholders and as well as the answers. Okay, so let's print this response. So if you execute this, now whatever we were asking, the system message, that means we are trying to give our model that what it want to reply and what is the question. So now the response contains, yes, a summary of the solar system. So it is like the entire metadata where it contains the content, okay, and Mercury is the closest to Sun, Mars. So it is something we cannot. It is also having, if you observe the new line characters, right? So if you observe this, the entire message was stored in content. Content is an object here, it has been used. So let's use this content. So by simply printing that response.content. Now we will get the actual uh, answer, how the response stored the data. Yes. So we got exactly the 5 points. It's a brief overview of the solar system. The solar system consists of 8 planets. So this is output what we will expect like a primary teacher. Now the same thing we will update with now chain of operations. Okay. So for the same thing, I will be giving reinitializing your system and question not required, but if you want to give it, you can also give. So I'm just giving your both system and question and also till here messages. Now instead of giving a question, what I will do is, so as I've given the template.invoke where I'm giving all these values, okay. Now what I will do is I'm going to create something called as chain. A chain, what we'll do is we'll create template, the template variable what we have used, and we are also, I'm going to use this chain operator. Now this chain operator, what I am going to use? LLM. Now this chain contains the answer of template LLM. Previously what we have done, we are invoking the question we are passed to LLM. Okay, now this LLM, whatever the model, so the LLM was initialized with your URL, that means where the server has been installed, and within that server it is going to invoke a model whichever we have initialized with. Now what we are doing here is we are executing this chain of operations. First template will be executed, followed by the response of, that means the output of the template will pass to your LLM. Okay, so if you just execute, let's execute this. Okay, now chain contains something. For suppose if you want to print the chain, we will see the contents of the chain as well. So this is what the chat prompt template. It contains the input variables, points, okay, all the partial variables. It contains system message prompt, okay, the prompt, school, whatever it is. Okay, so let's not do this here because it is anyhow the metadata where we cannot reuse them actually. Now what we'll do is, now the same thing what we have done, instead of invoking your template, we will invoke your chain. So we will invoke this chain, and in this chain, so the same thing what we have given, let's give this, not retyping it, and let's print. Now we were passing the contents, that means the school variable, the primary, like topics contain solar system, points can be 5 to the chain. Now chain, whatever chain holds, the chain holds the template and LLM. And the entire response of the chain, with the help of chain, it will execute with the template and LLM, and we are getting the answer. Okay, so that's how. So similarly, if you try for another response, let's give with another response like this. Let's give it as PHP, such that it will update the response similarly like chain. So it is also not going to take more time. So same thing, but it has been enhanced. This is what we can expect with the help of your chain operations. For suppose if you want to just print the response, we will get the actual metadata, whatever we have, as we have seen. So instead of doing that, that's the reason we are actually invoking the content. So instead of getting all this entire metadata. Okay. Now, so we'll go more in deeper. So instead of getting this content data, to get only this response, so instead of invoking this content, we have an another class called as output parser. Anyhow, we will see that in your next session. In different output parsers we have. So for that, we can actually use your Langchain core. So in your Langchain core, so we will be using output parsers. So output parsers is one of the package where we can import structured output parser. STR output parser is your structured output parser. So in this output parser now I will increase the chain. So I will give template and I will pipe it with your LLM, and also I will pipe it with your structured output parser constructor. Now I will give the response is equal to chain dot invoke. Okay, whatever we have given here, the same thing. So let's copy this. So instead of getting this, okay, we can use structured output parser. Now let's print the response. So previously we have print response, we got the metadata. Now if you print the response, we should get the actual output since we are piping the structured output parser class. Yes, the same thing whatever we got when we use your responsive content, it can be achieved with the class called as structured output parser instead of invoking the response.content actual human the AI message contents. Okay, so this is how we can use chain operations especially. Okay, so this is a very good usage of your chains. Now, next we'll go for your parallel chains. So each chain does something independent with the same input. Okay, so for example, one chain generates a fact, another chain generates a poem, like that. So that means we are going to use another the same example, but we are understanding the fact. Okay, now whether it is okay to, because poem generation, whatever poem we are generating, it can be fictional, but we are trying to generate the fact as well from the generated AI message from the model, and as well as we want to give that as we want to generate a very good interesting poem. That is also that will be depending on the model whatever we are using, but we are using Llama 3.1 billion parameter. It depends on the model which was actually installed in our local machine. Okay, so we'll be using both same input, but it depends on different outputs as well. So that's the reason we will try how this parallel chain will even work. Okay, now for this to using, so what we'll do first is let's analyze. So we have already got an AI message in the place of response. So for that, let's analyze the result. So for that, I'm going to use a variable called as analysis prompt. So in this, I'm going to use chat prompt template. So in this chat prompt template, I'm going to give a prompt to analyze. Okay, I'm going to give something like this: analyze the following text. So the text is the response what it is going to generate. So previously I got some contents in the response where I got 5 solar system key points. So I'm going to take that. I'm asking what your model should do. So let me close this so that the error lines will go. Okay, yeah. You need to tell me that how difficult. So I'm asking the model the generated response how difficult it is to understand. How difficult it is to understand. Okay, and I'm also asking to please answer in one sentence only. So we are going to give one prompt to the generated response. I'm storing that result in your analysis prompt. Now I'm going to check by using your chain operations. So I'm just creating a variable called as fact check chain. So where I'm giving this analysis prompt and your LLM and your structured output parser. Now the fact chain contains, okay, whatever the analysis, because the analysis prompt will have a result and that will be getting sent to your LLM as a prompt input, whatever we are giving, and it will be structured and that result will be stored in your fact check. Now I am going to invoke. So because we should invoke, right? Without invoking, it cannot be generating your AI message. So what you are expecting. So we are taking that response. That response will be passed. So that response will be passed. Let's print the output. This text may be challenging for traders due to its simplicity and lack of technical jargon or complex astronomical concepts requiring explanations or additional context to clarify the information. But that means it has been analyzed and it is also telling how it was difficult to understand and it is giving us the answer. Okay, so the spelling was not correct. Let me resend the prompt. Anyhow, the model will understand the context of the sentence, so it's not a problem. So I would rate this text, so it has been giving it in more refined, because when I rerun it, so it was actually generated a new AI message. I would rate this text as moderately complex, requiring some background knowledge of astronomy and planetary characters, but not so complex that it would be overwhelming for a general audience. So here we are taking the answer and we are that response we are passing it through a prompt again to the model and we are generating another new AI message from the generated response. So that was easily possible with our chain of operations, what we have done. Okay, so now let's give this in more refined format. So I'm just going to give like composed chain. I'm going to create another variable for composed chain where I'm going to give the response. Okay, so I want to give this doubles. So I'm going to change the result, whatever we got from chain, I'm going to store. I want to pipe this with your analysis prompt, and I want to pipe this with your LLM, and I want to pipe with your structured output parser. I'm going to use 4 results now in your composed chain. Now I'm going to use this, I'm updating your output. Again I am pass this using your composed chain. I'm going to invoke, see how complex we are creating, but it will work this seamlessly, and I'm updating. Let me give this now, because till now it has been referred the output like PhD. Now let me give like elementary. Okay, now we are trying to give it as elementary. Okay, now we are going to give the topics as well. So the topics, let it be same solar system, because solar system. Next to the number of points that you want to generate. Now let's print the output. We are not printing the actual output. Okay. The text assumes high level of knowledge about astronomy and space exploration with complex concepts. Even though we are giving it as elementary, it might consider it as, because if to get more reasonable output, let's rerun this such that it might understand the school variable what we have passed, because the variable what, so it has been given some different output now, because now it has been reiterated with a value called as elementary. The previous response what we got it like a PhD, now it has been reiterated like elementary, and it's a basic, because we are not seeing the actual output, but it stores the actual response what it generates, and that has been analyzed by a prompt what we have sent here. So this is how we can execute them, these things in a very sequential manner what we have seen. So this is what the sequence is following. First it is going to execute chain, next analysis prompt, next LLM, and structure parser. Let's go for the parallel chain. So as we have discussed, again let's reinitialize. So I'm not, okay, let's reinitialize the code. So whatever we have seen here, that is that it will be more clear because it has been initialized at top more. Okay, let's initialize still here the template. Okay, so we are reinitializing your system, question, messages, and template. Now let's update your fact chain. This fact chain will contain your template, your LLM, your structure output parser. Okay, now let's update your output again, once again. So output which contains your fact chain dot invoke. So this invoke. So let me copy this, which will save our time. We'll give only 0.2 points here. Okay, let me give it as primary. Okay, now let's print the output. Yeah, you got this 2 points, very simple. Now let's update your question. Now the output whatever we got, let's generate a poem from this. So for this I am updating your question. So this question is whatever human message that you want to give using your from template method. So in this from template I am asking, I am giving a point to write a poem on whatever topics we are giving. Okay, in how many sentences? Okay, that means lines. So now the question has been updated. Now let's again pass your messages is equal to the list of system message and the updated question now. Okay, now we are going to use again the template is equal to chat prompt template which contains your messages. Next, now we are going to create something called as poem chain where we are passing your template, piping it with LLM and piping with your str output parser. Okay, now let's invoke your poem chain now. So where I am again creating your output is equal to poem chain dot invoke, and I should pass again these values, whichever values we are, because this is different. So again I'm passing the same. Okay, and now we are going to, because this poem chain contains the question which contains the prompt like to write a poem on the generated int. Let's print the output. Something is missing. Topic is there, school is there. Oh, here it is sentences. Poem, we want to generate two sentences. Sun at center holds the stage, planets orbiting in their designated age. So yes. So from the generated response, it is going to give a poem with two sentences like this. So this also we can use. So to be more precise, whether it is actually executing parallel or not, we have a class called as runnable parallel. So that can be used from your Langchain core. So Langchain core, we have a package called as runnables. Okay, so in this runnables, let's import your runnable parallel. So we have this class, runnable parallel. Now from this runnable parallel, I want to use the fact, where I'm storing your fact chain and as well as the poem. So I want to use these both to get executed the same, like parallel. That's what the parallel execution I'm assuring it to be happen. So let me execute this. Now let's use this chain. So let's invoke this chain again, because now we are using your parallel execution with the help of runnable parallel class. So let me give the same, and also let me add your points as well, because let me give points as well. Okay, points. Give 5. So I'll give 5. That means now see here what was happened. Previously we are created here with the number of points, but here when you come here only we are giving the sentences. Now here parallelly we are trying to generate this part and also this part. So these both parts we are trying to parallelly execute with the runnable parallel class. That's the reason we are even giving the topics, the points, and the school type, and as well as the number of sentences at the same chain. Okay. Now let's execute this. Let's print the output. So let's see how it will come. Yeah, it came fact. So let us organize, even though the structured output it is there, but structured output is with the poem chain. So let us reorganize this. So what I will do is we will print the data by data, and also let's print this with new line characters even. Two new line characters, and also even now print the poem, because we are storing the poem. So from the output we are asking only to get the poems separately. Okay. Let's see. Now it should be the fact actually where the fact chain will exist. So this is the fact chain and this is a poem. So from this entire 5 sentences we are generating the sun is center. It shines so bright. Planets orbit around it, a celestial delight. So it is generating a poem from the generated AI text. So this is how we are assuring to execute it in parallel. Now let's see the next type of chain called as chain router. Here simply we are here to create some routing method. So we are going to create one method simply with some different output. We will go with definitely. Okay, so the different output we will be expecting from by creating a method called as root. So we are just examining the input. From the input we will route the chain to which chain to get executed. It's a simply user defined method execution. It's just routing your chain, which chain to get executed. So we'll do some different example. We'll do with some different example now. So let's give a prompt. I will update my prompt, so we might get bored with our solar system. So with this solar system, let's given the user review. Now let's take user reviews below and classify it as either being about positive or negative. So we are telling our model to give whether the review is positive or negative. Okay, and also we are restricting the answer to come like this: do not respond more than one word. With more than one word. We are also telling this. So for this, we are giving what review is. Let's differentiate, because we are going to pass that variable from the analysis. This is actually not needed, but let's try. Now we have created a prompt. Now this prompt, let's give to a template. Okay. So let's update your template with your chat prompt template by using your prompt template method and passing this prompt. Now let's chain it. Chain template with LLM with structured output parser. Okay. Now let's give a review, for example, just to understand so how it is actually working. So let's give a sentence like this. Thank you so much for providing such a great platform for learning. Platform for learning. I'm really happy with your service. So we are just giving a review and we are just understanding how this chain is going to work. Make your chain together. So for that I am let invoke your chain by passing your review. Okay. Let's execute this. So as per the given sentence, it should give positive. Yes, it's giving positive. So it understood the prompt now. So we are passing it to your model, and we are expected with one output called as positive. We are actually engineering. That means we are creating a prompt such that your model should work fine. That's how we are doing. Now let's create, because as we need to route the chains, what for suppose if it is a positive review, how your model should react. So for that, let's create two values with some positive prompt. For suppose if it's a positive prompt, that means we should route it, right? So if it is a positive prompt, so we are trying that that means we are making your model to understand what are you. You are expert in writing reply, okay, for positive reviews. we are telling what you are to the model. You need to encourage the user to share their experience on social media, and we are taking that review. From the review we are making what is the answer as well. This is a positive prompt. It means if it is, we are going to call this positive prompt. So for this, let's create a template called as positive template. So let's use your chat prompt template, and from template, so let's pass this positive prompt. Now let's create a chain called as positive chain, where we should create a chain of operations using the positive, where is my template, positive template followed by LLM followed by your structured output. So whenever it's a positive prompt, it is going to execute this positive prompt. Now we have created a positive prompt. Similarly, let's create your negative prompt. So negative prompt. So in this negative prompt, now the same way we should also tell if it is a negative prompt. That means, for example, if it's like a feedback, if you are taking a feedback from the customer, so we are just, if it's a positive, we are just giving a thank you. If it's a negative, also we should say thanks for the review, but we should also we know how polite the company should be like. Even though if it is a negative review, we should be able to understand the feelings of the customer, and also we should apologize even. So that's the reason we should write. We are just writing an apologize a reply for the inconvenience cost. Okay, so the inconvenience cost to the user. So we are giving a prompt like this. So a model will understand what to reply and how to reply. So if you check the output, you will just wonder. Concern on, for suppose if there is any concern, let them mail to you. So let's give some ABC @xyz.com. So let's give, we are not giving any potential working mail ID here, just to have, we are telling your review model to um, just response to the like this. Now similarly we should create this negative template. So for that also just copy this. So instead of positive template, create negative template, and here we should give negative prompt, and also let's create negative chain here. Negative template available. Now we have created both positive and negative. Now let's route. Let's create the route of operations. What we can do. Um, for that, let's define a route called as define route, and passing the value whatever we got. So in this, if the review was positive, if the review was positive in info, that means it is going to understand it like a sentiment. Okay, dot lower. We are understanding it like this. So if it is so, we are about to return your positive chain. Else, return negative chain. So we have defined root. Now let's uh, execute the basic review. For that, I'm going to use Langchain lambda. So for that, we should import it from Langchain 4. So where you have runnables, import runnable lambda. So now we are going to create another thing called as full chain. So in this, I'm going to give the sentiment as chain. Okay, and I'm going to give the review as whatever review value we'll get. So for that, I'm going to use your lambda. Okay, hope you know how lambda works. So basic operation, very useful in our Python to analyze the things. I'm going to chain this with your runnable lambda, where I'm going to pass your root function. If we just print this full chain, we'll understand what are all it actually holds. So it contains the sentiment, so it contains the input variables, partial, the message, the human message prompt. Here we are actually invoking. So it is going to take the review. So it was came from that one where we have initialized it previously here, where we have given here. So it's going to take from this prompt. So the entire data was stored here now. Now full chain contains the entire data. Now there is no doubt that it will work fine. Now let's give one review and let's execute how these chains are getting routed. So let's give a review. So I am not happy with the service because we are trying for a negative things, and let's check how our model is working. So let's give a review like this. For this we should invoke your full chain, right? So output is equal to full chain dot invoke. So what we want to pass, we want to understand uh, the review. So we are not doing that, but your model will do what review it is, and we are going to store that, and that review will be stored, get back to the model, that means the chain where we have created, and it will tell us. So let's, now we should hear from the model. Now we know that from the sentence it's a negative, but from the model we'll understand if it is negative, what your model is doing. Because there are some series of chain operations. Yes, we got a response. It is just giving, okay, response. I want to start by apologizing for the inconvenience you experienced during your recent visit or service interaction. Now we understand that our service did not meet your expectations, and for that we are truly sorry. We take all feedback seriously and would like to learn more about what went wrong so that we can improve. So it is just apologizing, and it's also provided the email ID what we have provided at previously whenever we have created a prompt for the negative, because the negative prompt whatever we have suggested for your model to get reacted, so it is going to take that into consideration, and here it is able to provide that as an output, and your input will help us identifying areas for improvement. So this is how your negative. Now let's give the same by passing one positive review, and we will see how uh, this model is going to give. So for that, let's give one positive review. So I will give, I'm very much happy with your service, and um, I will definitely recommend your product to my friends. So now it is going to understand the sentiment. Okay, we are not giving which uh, um, like which prompt we should invoke, which chain it should invoke. The full chain have the response to invoke according to the review. So we'll see. So the previous one it took 10.3 seconds. So it gave. So it's a rewritten answer that agrees that. So I'm thrilled to hear that you are. So we are. So actually it came in this thing, but it should come in this. So let's re-execute if possible. So we change the view. Let's re-execute so that it will come in new lines. It's not structured actually. Yeah, now it came good. So if you have any output, that means it might be formatting error. Model might not. Now we are actually making our model to rethink to give the output. That's the reason I'm re-executing every time if it was not in the format. Okay, so now it was giving. I want to start by. Oh, sorry, it was given as I am. It was giving the wrong thing, right? Mm-hmm. It is giving the wrong sentiment. Yeah. So it was giving twice. So let us re-execute. Yeah, it is coming as positive. Thank you so much for taking your share of wonderful feedback. We are thrilled to hear of the matter expectations. It was not came in a more structured way, but it was giving like so. For that, we can use more output forward what we have seen for your fact to get response. So this is how we can route our chains. Okay. So similarly, we can use runnables. What we have seen more runnable lambda, runnable parallel. These are also different runnable classes we can use actually. So we can use other runnables as well. Okay, so runnable lambda is there, runnable sequence is composed step sequentially, like runnable parallel, run steps parallel, what we have seen. We can apply a chain to each item in a list by using runnable map class. And runnable pass through just returns the input. Runnable branch, like in if else logic tree, we can actually use an if else logic tree by using runnable branch. And runnable assign, it can assign new keys to the input dictionary. So let's use uh, uh, runnable pass through now. Only one of the runnables, so we can use any of them. So we can go with the runnable pass through. So we will test how they are working. So for that, from your Langchain core, so from your runnables, because all this are part of your runnables package, let's import your runnable pass through and runnable lambda as well. Now let's create now new things. Let's create. So we have seen so many things. Now from this runnable pass through, we'll understand how to pass the chain of operations to the next one. So for that, let me define a function called as char counts. So in this, let's give text. So we will, yes, it's a very simple thing. We are just understanding for the AI message it has generated, we are going to count the number of characters and as well as number of words. So very simple code. So for that also, for that we are going to use runnable pass through. So we are going to, that means the AI message, what it has been generated, we are passing this as an argument to your function called as character counts and, sorry, uh, your number of words. So for that we have text dot split function. We have understood already split function previously. Now let's give a prompt. So for this, we are going to use start prompt template. We are going to use from template. Now let's give a prompt. Explain these inputs. So we are going to ask inputs in 5 sentences, and we are taking those inputs from the uh, next line, like input 1 and input 2. So we just print the prompt. So it is about to understand what are the inputs. Now we are going to let's give those inputs. What are they? So so before giving the input, let's create the chain. Um, the chain is equal to, first give the prompt, next LLM, and let's give your structure out parser. Let's hope it will work now fine rather than the things. Now we should invoke this chain. So let's give the output. Chain dot invoke. So we should give inputs now, because for the input 1 and input 2. So let's give very simple sentences by passing. Now first we should know what is the input 1 should be. So input 1, we should give a string of data. Let's give Earth is a planet. Okay, this is 1, and let's give another input. Input 2. So input 2, let's give sun is a star. Okay, so let's print the output. Okay, so yeah, that is what actually given this statement appears to be an incorrect assumption that is actually a terrestrial planet, not a planet. Oh, it is going more specific. That's the reason we got like this. Okay, so but not, it's not an issue, because that's not we are expecting from this actual thing. So let me re-execute this. It might give you new message. Yes, the term planet represents an object of yeah. So it has it will, so for every rerun it is going to generate a new AI message. Okay, now let's uh, use your runnable pass through as well. So let's, for that I am just rewriting my chain by giving the prompt and giving the LLM. Okay, and structure output parser. Other than this, now let's execute your char count. So the char counts. So the message what we actually pass, the method what we have created, that's what the character counts. So we will take the help of your runnable lambda. In this runnable lambda, we are going to pass your char counts method. Next, let's count the words. So word counts. Again, let's use your runnable lambda where we are going to use word count. Now, for the output to get, so let's use your runnable pass. Okay. So I'm not given comma here. That's showing the output. Now again we should invoke the chain. So let me re-initialize your output. Chain dot invoke. So in this invoke, again I am going to give this, I will give the same thing. So use the same two lines here. Now for the generated AI message, it is going to count the number of characters, number of words. So whatever runnable lambda we are getting, so that will pass through the chain of operations. Okay. So even though there are two different methods, okay. So the character is 53 and it also counted as 114 words. This is the output actually. From Earth refers to the planet. So from here to the entire things, It has been counted the number of characters and as well as the number of words. Okay, so next coming to your custom chain, where we can use a decorator called as chain. So it actually not part of Python, but to understand this, so simply we can use this chain decorator custom and we can execute this custom chain. Custom chain is whatever we execute by our own things, by our usable runnables. So it depends on the purpose why we are actually try to execute. So previously we have seen so many sequences. So we have seen sequence of operations every time. Okay, so we have created sentiments of a given sentence, and also we have tried to uh, identify to generate how to generate a poem as well. So these are all the customized thing as well. We are actually doing this with the help of all the classes. Okay, so thank you. We'll see in the next session. Thank you.